Hi, and welcome to Science with Mrs. Stone from Advancing Science at Gettysburg College. This lab activity is called How Low Can You Go?, which is an investigation to help us understand why road salt works. Many people think that the salt we add to the roads in the winter will melt the ice. Let's test that idea. Pour some salt on top of an ice cube and then put the ice cube in a cold place. We know that warmer temperatures will melt our ice cube, but we want to see if the salt will melt our ice cube, so it's important to keep the ice cube in a cold place. I put mine outside. It was about 28 degrees Fahrenheit this morning, lower than the freezing temperature. We'll check back on our ice cube at the end of the lab. For this lab, each group will need a Vernier Lab Quest, a Vernier temperature probe, a beaker containing about 100 milliliters of ice. You can just fill the beaker about half full with ice, and 1 teaspoon of table salt. Start by turning on the Lab Quest. You'll find the power button in the upper left corner of the Lab Quest when you're holding the Lab Quest in a landscape format. Once you get it powered on, the main screen will display as you see here. Our next step is to plug in the temperature probe. The temperature probe has a white plug on the end that looks like this, and you'll want to plug it into the CH1, the channel 1 plug that's on the end of the Lab Quest. Go ahead and plug it in, and you'll know that you did it correctly when you see this red box pop up on your Lab Quest screen. The Lab Quest will automatically identify that you've connected a temperature probe, and it should give you what we call the live temperature reading displayed here on the main screen. So mine's showing about 22 degrees Celsius, which is right about room temperature. If you don't see this red box on your screen with the live temperature reading, double check your connection up here and make sure that you've got it clicked into channel 1, CH1 on the side of the Lab Quest. The Lab Quest defaults to collecting temperature data in degrees Celsius. Scientists like to work with scientists from all around the world, and the rest of the world uses the Celsius temperature scale. So I'm going to go ahead and run this lab using the Celsius scale, but if you prefer to run it in Fahrenheit, all you need to do is take the stylus. There is a stylus on the back side of the Lab Quest device you can remove and use. And all you need to do then is just tap on this red area that gives you the temperature. You'll see this little pop-up that says change units, and then from there you can change between Celsius and Fahrenheit depending on what you prefer. Our next step is to get our Lab Quest ready for data collection. So over here on the right hand side of your Lab Quest screen, you'll see some information. We're looking for this area that says duration. Right now it is set up to only collect data for 180 seconds, which is about 3 minutes. We will need a little bit longer of a data collection period. So go ahead and tap where it says duration. That will take you to this next screen right here. You want to tap in the duration box, and that will pop up a keyboard. Change 180 seconds to 600, and then just hit the done button. It'll take you back to this screen. You can hit OK. Our Lab Quests are now ready for data collection. Well, let's begin by holding the temperature probe in the air. We want to get a reading of the room temperature. So the temperature probe is reading from the silver tip at the end of it. So make sure that silver tip is in the air. It's not in anybody's hands. That way we can get a nice accurate room temperature reading. To begin our data collection, you'll just tap this green play button that's down here in the lower left corner of your Lab Quest. Once you start data collection, it will automatically take you over to this graph screen. And if we look in the upper left corner, we can see this first symbol is what we call our meter screen. And we're on our meter screen when we see this red box. The second symbol is our graph screen, and that's what our data collection screen will look like. After a few seconds, a line will start to appear on your graph screen, and this will represent the room temperature as long as nobody is holding on to the tip of that temperature probe. When you look at a graph, it's always important to take a few minutes to understand what is being presented in the graph. So take a moment to look at the y-axis and the x-axis to see what is being graphed along our screen here. You can see that we have temperature on the y-axis and time on the x-axis. So the LabQuest will generate a line graph to show us how the temperature changes over time. Keep the temperature probe in the air for about 30 seconds or so. You want to have enough time to get a nice flat line here to represent our room temperature, to represent a stable room temperature. You can always check the current temperature over here on the right hand side of your screen. This will give you your live temperature reading at any point. And down here at the bottom, this will tell you how far along through your data collection you are. So right now I'm about 24 seconds into data collection. Once you get a nice flat line here at room temperature, the next step will be to fill a beaker with about 100 milliliters of ice, again about half full. Then you'll go ahead and put the temperature probe into the ice in your beaker. Hold the beaker in your hand and use the temperature probe to stir the ice. As you stir, you want to be sure that you're stirring slowly but constantly. The ice should not be flying out of the beaker. As you do this, watch the graph line to see what happens to the temperature. You should see a sharp drop in the temperature. You want to keep stirring all throughout our experiment today. Keep stirring until the temperature stabilizes. We know it's stable when we get a nice flat line like you see right here. And it will stabilize right around the freezing point for water. If I double check my current temperature, I'm over here at about 0.7 of a degree Celsius, so just a little above the freezing point of water. Now, if you take a look in your beaker, you should notice that some of the ice has started to melt and you'll have a little bit of liquid water in your beaker. Think about why that is. Take a look at your hands holding that beaker. It's our body temperature. It's starting to warm up some of the ice that's in our beaker, and it will cause some of that ice to start to melt. Keep stirring the ice, and now it's time to add our salt. Don't take the temperature probe out of the ice. Just keep stirring and add about 1 teaspoon of table salt to the ice in your beaker. Keep stirring. Keep stirring to dissolve the salt in that little bit of liquid water that you had in the bottom of your beaker as a result of your body temperature starting to melt those ice cubes. You should see another sharp drop in the temperature. And if we take a look at our live temperature reading over here, you'll notice that I'm now below zero, well below zero. I'm at -13.5 degrees Celsius. Keep stirring until you get the temperature to stabilize as another flat line on your graph screen. Once the temperature reading has stabilized again, you can stop data collection. To do that, you'll just click down here in the lower left corner of your LabQuest screen. You should see a red box. Click that red box. It will turn back into a green play button. That way you'll know your data collection is complete. The LabQuest will automatically stop data collection after 600 seconds because that's how we set it up at the beginning. But you can stop it earlier than that if you are ready to proceed on to the next step of your experiment. Take a look in your beaker. You should now have lots of liquid water in there, but that water is salty. We've dissolved our salt in that water. Once the data collection is complete, you can use the LabQuest to help analyze the data. The first step is going to be to sketch our graph in your journal. So take a moment with your journal, draw the y-axis, draw the x-axis, label each of those. Temperature belongs on our y-axis, time belongs on our x-axis. Then come into the graph area and do your best to replicate this stair-step-like pattern that you see on your graph screen. The next step is to label each of these flat portions that you see. So I've gone ahead and labeled my first part right here. This first flat portion represents when I was holding the temperature probe in the air and I was measuring the room temperature. You should also add a label to this flat portion of your graph. What was happening during that flat portion? Where was the temperature probe? And also this flat portion of our graph. You should have a total of 3 labels added to your graph, 1 for each flat portion. Now it's time to find our mean temperature for each of these three flat portions of our graph. To do that, you'll take the stylus and click at the beginning of the first flat portion. Click and drag the stylus across that first flat portion of the graph. That will highlight that first flat portion of the graph in gray. Then come to the Analyze menu, choose Statistics, and then Temperature. Then over here on the right-hand side of your screen, you'll see a bunch of information pop up. You want to look for the mean down here, and you will add that to your data label. So if I come back to my data label for the temperature probe in the air, and I found the mean for that flat portion, I would go ahead and add my mean temperature here, which is about 21 5/10 degrees Celsius. Once you have the mean temperature for your first flat portion, you can repeat that process. Click and drag along the second flat portion of your graph, choose Analyze, Statistics, Temperature, and then look to the right side of your LabQuest screen to record the mean for that second flat portion of the graph. Repeat this process for the third flat portion of your graph. You should now have a graph sketched with 3 labels. Each of those labels should indicate where the temperature probe was located. Was it in the air? Was it in the ice? Or was it in ice and salt? Also on those labels, you should have the mean temperature for each of those 3 flat portions of our graph. To continue our data analysis, if we had lots of time, we would repeat this experiment several times to make sure that the data that we collect is accurate. We don't have time to run the experiment multiple times today, but we can combine our class data to increase the accuracy of the data that we collected. So let's look back at your graph sketch and have your teacher help the class create a class data table that looks something like this. You'll need 4 columns. The first column will be for each group. The second column will be for our room temperature, the third column for ice only, and the fourth column for ice plus salt. You may need extra rows in your data table depending on how many groups are participating. Once your teacher has put together a class data table, add your mean temperature data for each of the 3 parts of our experiment. So if I was in group 1 here, I would come and add my mean temperature for that first flat portion when my temperature probe was measuring the room temperature. I would then add my mean for the flat portion that represented when my temperature probe was only in the ice, and then finally my mean for the flat portion when the temperature probe was in the ice and the salt. Once all of the groups have added in their data, then you can calculate the mean. Hopefully you remember how to do that from math class. If not, you can take a moment to talk with your class about how to calculate the mean for the room temperature for all of the groups that participated, the mean for the ice only for all the groups that participated, and the mean for the ice plus the salt. Let's check back on our ice cube from the beginning of lab. Remember that we poured about 1 teaspoon of salt on top of this ice cube and set it outside while we did our experiment. Notice that we still have an ice cube with salt on top. So what is happening? We observed that salt doesn't melt the ice. We still had an ice cube with salt piled on top of it. So how does it work? How does salt work to keep our roads safe during the winter? Well, salt lowers the freezing point of water. The normal freezing point for water is 32 degrees Fahrenheit or 0 degrees Celsius. We measured that in the second part of our experiment with just ice in our beaker. But remember, we held the beaker in our hands. Our body heat warmed the beaker a little bit and caused a little bit of the ice to melt. Remember that we saw a bit of liquid water in our beaker before we added the salt. Then we added the salt. The salt dissolved in that little bit of liquid water. So if we look at our second picture here, the blue circles represent water molecules and the orange circles represent salt molecules. So this is the second part of our experiment where we put some salt into that little bit of liquid water that was in our beaker. And those salt molecules actually got in the way of the water molecules so that they weren't able to organize into a freezing structure. This is what water looks like when it normally freezes. Again, these blue circles represent our water molecules, and when we get to the freezing point of water, those water molecules slow down and they start to organize themselves in this pattern, and this is what we call ice. But when we add the salt in there, the salt blocks the ability of the ice structure to be able to form. So salt doesn't melt the ice. It lowers the freezing point of water so that ice won't form on our roads when it's less than 32 degrees Fahrenheit or 0 degrees Celsius outside. This only works until a certain temperature, and we found that certain temperature in the last part of our experiment. At temperatures below about 10 degrees Fahrenheit or negative 12 degrees Celsius, the salt will stop working, and that's what we're seeing over here. So when we get below those temperatures of about 10 degrees Fahrenheit or negative 12 degrees Celsius, what happens is the salt gets pushed out of the way. So in this last picture we can see here that our salt molecules, these orange circles, have been pushed out of the way, and the water molecules will freeze as they organize into the ice structure. So salt works to lower the freezing point of water on our roads, but it only works to a certain temperature. Below those temperatures, salt is no longer effective to help us treat our roadways. Now it's time to clean up and get our materials reset for the next group. To restart the Vernier Lab Quest for the next group, make sure that data collection has stopped, so you want to make sure that you're looking at a green play triangle in the corner and not a red box. If you see a red box here, you want to tap that so that it comes back to this green triangle. Then you'll come up to the File menu, tap New, and then you can say Discard when it asks if you would like to save your changes. The Vernier Lab Quest is now reset, and the next group will have to start back at the beginning to make sure that our duration is set to the proper length for the next experiment. To continue our cleanup, you can dump the contents of your beaker into the sink, rinse the beaker to get rid of any salt, and leave it upside down to dry. Use a damp paper towel to clean off the silver tip of the temperature probe. This will remove any leftover salt so the next group can start their experiment without any salt contamination. Check the battery level on your LabQuest and let your teacher know if it needs charging. I hope you enjoyed this experiment today. Be sure to go home and share with your family what you learned about how salt actually works to keep us safe on the roads. It just lowers the freezing point of the liquid water. It doesn't actually melt the ice. Have a great day. Thanks.